Scientific notation and rounding. Before we begin, we need to recognize that place values have specific names. So there is a decimal point that's indicated here, and the name changes based on where the number is positioned from the decimal point. So this is the ones place, the tens place, the hundreds place, and so forth. So those are pretty familiar to everyone. But on the other side of the decimal point, we have like the tenths place. So tenths, THS, is added as the ending here to indicate that it's on the right side of the decimal. So tenths, hundredths, thousandths, 10,000ths, and so forth. Scientific notation has two parts. So a number written in scientific notation has the decimal part, and that's a number that's between 1 and 10. And an exponent part, it's 10 raised to an exponent n. So this is the decimal part times 10 to some exponent. Now with this decimal part, there can only be one number to the left of the decimal because it's a number between 1 and 10. So it has to be less than 10. 9.9 is the highest number, or 9.99999 would be the highest number. Only one digit can be to the left of the decimal. A positive exponent means 1 multiplied by 10n times. A negative exponent means 1 divided by 10n times. So a positive exponent means that it's a large number. A negative exponent means that it's a very small number, it's a decimal. So to convert a number to scientific notation, find the decimal part, then find the exponent. Move the decimal point to obtain a number between 1 and 10. Multiply that number, the decimal part, by 10 raised to the power that reflects the movement of the decimal point. So those are written out instructions, and not a lot of students do well with written out instructions, so I'm going to give you some examples. So if we start with the number 5983, so this is 5,983. If we want to convert this to scientific notation, we want to move the decimal so that there is only one place to the left of the decimal. Now this number doesn't have a decimal in it, so whenever a decimal isn't written, it's assumed to be at the end of the number. So we put the imaginary decimal point right here, and we're going to move it 1, 2, 3 places until we get one digit to the left of the decimal. So now we have 5.983 as our number. Well, we have to indicate that we have moved this decimal 3 times. So we would go times 10 to the 3. Now if we start out with a really small number and we want to express that in scientific notation, we would do something similar. So we're going to move this decimal, and here you can see there is a decimal in the number, and we're going to move the decimal to the right to ensure that there's only one digit to the left of the decimal. Zeros don't count. So we go 1, 2, 3, 4, and we would put the decimal here. So now we end up with 3.4. But we have to indicate that we have moved the decimal. And the way that we hold that value is by doing times 10. And since we move the decimal to the right, we have to say -4. So if the decimal is moved to the left to convert it to scientific notation, the exponent's positive. If it's moved to the right, the exponent's negative. Another way to think about this is if it's a big number, it's going to have a positive exponent. If it's a super tiny number, it's going to have a negative exponent. So I would like you to pause the video and try to work through these problems and convert these into scientific notation. When you unpause the video, I'm going to go through how to do it. All right, so hopefully you had an opportunity to go through these. We're going to get started. So for this first number, we want to move the decimal so that there's one place to the left of the decimal. So we're going to go here, 1, 2, 3, 4, 5, 6, 7, 8. So we're moving this 8 places. So we have 2.943 8 times 10, and we moved it 8 places to the right. Since we moved it to the right, and since it's a really small number, we would do -8. So now with the next one, there's no decimal in this number, so we're just going to put this imaginary decimal at the end. Now we're moving this 1, 2, 3, 4, 5, 6. 6 places. So to write this number in scientific notation, it's 1.29239, and you can remove the zeros. We're not doing anything with significant figures right now, so if you don't want to write the zeros, you don't have to. Otherwise, if you want to, you can. So we're going to go times 10, and since we moved it 6 times to the left, and it's a really big number, we're going to put 10 to the 6. So the last number here, very similar. There's no decimal in this number, but there is the imaginary one at the end. We go 1, 2, 3, move it 3 times. We end up with 3 times 10 to the third. We're putting a positive exponent because we moved the decimal to the left and because it's a large number. So how to convert these to scientific notation? I'd like you to pause the video and go ahead and try to work through these, and then when you come back, I will solve these. Okay, so if we look at the first one, we're going to move this 1, 2 places. So this becomes 1.14 times 10, and we moved it to the right, and it's a small number, so we have to put a negative exponent. 1.10, this is just 1.10 times 10 to the 0. Now we have to put times 10 to the 0 to get it in scientific notation because this exponent portion is a mandatory part of scientific notation. So if we go back to this slide here where I first talked about what scientific notation has, it has these 2 parts, so we have to write that part down, even though that essentially equates to 0. All right, so now we've got this number. We're going to put this imaginary decimal here, and we're going to move this 1, 2, 3, 4, 5, 6 places. So we get 5.345 times 10, and this is going to be a large number. We move the decimal to the left. We're going to keep it a positive exponent. How to convert to standard notation. So in this instance, we have a number in scientific notation. We want to write out the number as it would actually appear, as it would be a real number. So instead of this exponential form, we want it to be just a number. So in order to do this, you are going to rewrite the number 1.293. Now we have a negative exponent, and when we have a negative exponent, we know that this decimal, this is going to be a decimal number. It's going to be a really small number. So to make the number that we have here smaller, we would have to move the decimal to the left. So we'd have to go to the left 3 times. 1, 2, 3. And we would put our decimal there. Because when we were going from standard to scientific notation, we deleted the zeros, now we have to add back the zeros. So we would just fill in these gaps with zeros. So our final answer would be 0.001293. Now, some teachers like to teach move the decimal to the left, move the decimal to the right. But if you're converting to or from standard or scientific notation, it's going to change. So what I like to teach is if it's a big number, it's a positive exponent. If it's a little number, it's a negative exponent. Because that way, no matter whether you're converting to scientific notation or to standard notation, you're going to end up with the same answer. So here is this number in standard notation now. So now we're going to do this one. Again, we're going to start by rewriting the number 5.3982. Now we have a positive exponent, so we have to make this number bigger, and it has to be bigger by moving the decimal 4 places to the right. So to make this bigger, we're going to go 1, 2, 3, 4. So our answer becomes 53,982. Now we look at this next one. We're going to rewrite this number, 8.7000000. And we have a negative exponent. We got to make this number smaller by 5. So we're going to move this 1, 2, 3, 4, 5. We're going to have a decimal here, and we're just going to fill in zeros in these gaps. So our written out number now becomes 0.000087, and then all those zeros at the end. Go ahead and pause the video and try to work through these problems. Okay, so again, we're going to write out the number 3.0900. 3 means we have to make it a bigger number, so we're going to move this decimal to make it a bigger number by 3 places. So we go 1, 2, 3, and our final answer is 3,090.0. For this one, we have a -2, which means we're going to have to make this number smaller. So when we write out this number, 2.290180, we're going to move this decimal 1, 2 places to make it a smaller number because it's a negative exponent. And our final answer is 0.02290018, and then we can add those zeros. And this problem here, so positive exponent, got to make this a bigger number, 4.0090. We move this 6 places to make it bigger, 1, 2, 3, 4, 5, 6. We're going to then fill in the zeros, and we end up with 4,000,009,000 as our final answer. Rounding rules. So the rule for rounding is if the number is 5 or up, you're going to round up. If it's 4 below, round down. So we're going to go through some examples of rounding now. So round 0.0345 to 2 decimal places. So I'm just going to rewrite that number over here, 0.0345. And it says to 2 decimal places. So we're going to count 2 decimal places. This is 1 decimal place. This is the second. And we're going to try to cut off the number here. So we're going to look to the right now. If this number is 5 or above, we round the preceding number up. If it's 4 or below, we're going to keep the number the same. So this number, because it's 4, we're just going to leave it and drop off the ending. So this becomes 0.03. Okay, so with the next one, we have 0.00791. Now we want to round to the nearest thousandth. A thousandth is referring to the decimal place. So we have the tenths, hundredths, and thousandths. So this is what we want to cut off. Now when we cut this portion off, we need to know what to do with this 7. Do we round it up or do we round it down? Because this is a 9, 9 is above 5, we're going to round this up. So our final answer for this one is 0.008. Now we're not going to add zeros after this if we eliminate it because we're rounding to cut off a portion of the number. The whole point of rounding is typically to remove a portion of the number so that you can write less of the number. Now this one is another one, so we have 1.902 and we're going to round to the nearest tenth. So this is the 10th place, which means we want to cut this off. So looking at the 10th place, we're going to look one digit to the right. This is a 0, so it's less than or 4 or less. So we're going to just cut it off and not add anything to it. So our final answer would be 1.9. Continuing on, 1502. Now to the nearest hundredth place. This is the 100th place. So instead of cutting off, because this isn't a decimal, it wants just the last whole number to be at the 100th place. So the hundredths place is kind of where we're going to make our determining call. So we're going to look one to the right, and we can see that this is 4 or below. So in order to do this one, we're going to write 1500. We're going to keep the 5 the same and remove the digit 2. This next one, 1340889 to the nearest 10. So this is our 10 place. We're going to look to the right, to the ones place, and this is 5 or above. So we now know we have to round this guy up. So this becomes 1340890. So that's the nearest tens. Round 3.500 to the nearest whole number. 3.500. We want the nearest whole number, so not the decimal. It would be the number that's not the decimal. So when we want to cut off the decimal portion, we're basically going to be looking at cutting that much off. We look to the right, and it's 5 or above, so we have to round this to 4. So our nearest whole number for 3.5 is 4.